All right, welcome back. So here you can see I already solved number one, and I kind of gave an example of what it should look like on the graph, right? So if I've got something here, oops, I drew the wrong line, but kind of means the same thing. But here you should only get one solution. Here's why. Because when you go to solve this, x squared plus 9 equals 9. You subtract the 9, and you end up getting a 0. If you're taking the square root of 0, that's going to be the one case where you end up with only one solution. Because think about it, there's no such thing as negative 0, no such thing as positive 0. So there's only one answer here. You plug in 0, and you still get 9 as an answer. Or you could have just recognized that you were going to get 9 as your answer anyway. So let's look over here at the graph of what it should look like when you get just one answer. So if I have a parabola representing the x squared plus 9, and then I just have a straight line representing the y equals 9, right? So it should look like this. And you're going to notice that the one answer that you're going to have is the vertex. So if your vertex is where something crosses, think about that. That's the only solution at that point. You can't cross the vertex and another point. It's not necessarily possible to really do that. So that's when you're going to get just one answer here. Okay, so let's move forward to number 2 and 3, and we're going to work on this all the way through together. So number 2, y equals negative 5x. Y equals x squared minus 3x minus 3. Okay, using substitution, we're going to set these two things equal to each other. So we get negative 5x equals x squared minus 3x minus 3. Now I'm going to try and get one side equal to 0. So I'm going to add 5x to both sides. That's going to give me 0 is equal to x squared plus 2x minus 3. Okay, now I evaluate which method is going to be easiest. Notice in number 1, our method was actually using square roots. So we solved that last one by square roots because it was the easiest one to use. Here, we might have another case where factoring is actually the easiest to use. So let's ask ourselves, what multiplies to make negative 3 but adds to make positive 2? Well, the answer is negative 1 times positive 3, because these two multiply to make negative 3, but they add to make positive 2, okay? Zero product property rule says x minus 1 can be equal to 0, or x plus 3 can be equal to 0. Solve for x in both cases. We get x equals 1, and we get x equals negative 3. Okay, so I have my two x values, which means I'm going to have two solutions here. So I'm going to plug these back into either of the equations and solve, okay? So let's go ahead and plug the 1 back in first. That one's pretty easy. Notice that this is the easiest one. Don't try and plug it back into this. It's going to be a lot of work that it's just not super fun to deal with. You can get the same answer, but we're just going to use this one. So we're going to use y equals negative 5 times 1, which is just equal to negative 5. So that means my first point is 1, negative 5. That's one of my answers, okay? Second answer, plug in negative 3. Y equals negative 5 times negative 3 equals 15, which means my answer is negative 3, 15. Which means my two answers are right here, okay? Those are my two answers. And since I already have them blocked or boxed up, we'll just leave it like that. As long as if you box the answers, you're fine. Okay, so 2 points where they're going to cross right there. Now next, or I might just label this solutions right here, okay? These are the points where they're going to cross. All right, number 3. Number 3 is y equals negative 3 x squared plus 2x plus 1. Y equals 5 minus 3x. Okay, set them equal to each other. Negative 3x plus 2x plus 1 equals 5 minus 3x. Sorry, I meant to say negative 3x squared. Set one side equal to 0. Add 3 to both sides. We get negative 3x squared plus 5x plus 1 equals 5. Minus 5 minus 5. Negative 3x squared plus 5x minus 4 equals 0. Okay, so now here's where I have to evaluate again. Okay, what method is actually going to be the easiest here? So if we're going through our 5 methods, we know graphing is the worst one, so we're probably never going to use graphing. Factoring we only want to use factoring if it's going to be easy. Since I have an a value here, graphing is not going to be that easy. There's no perfect square, so I don't want to use square roots, and completing the square, I also have to have an a value of 1 and a positive b value. So I think that none of those methods are going to work, so the only method that I think is going to be kind of nice for this one would be the quadratic equation. So let's go ahead and use the quadratic equation for this one. So if you remember right, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I just rewrote it from memory. That way I could have it right there and just go straight from this. Okay, so x equals negative 5 plus or minus the square root of 5 squared minus 4 times negative 3 times negative 4 all over 2 times negative 3, okay? X equals negative 5 plus or minus the square root of 25 minus 48, I think is what you get here. Yep. All over negative 6. And then this is where I actually noticed something. So this is going to be negative 5 plus or minus the square root of negative. Well, what does that create? That makes, is that negative 23? I think it is. But I don't really care what it is because I know that it's going to be a negative number because this number is bigger than this number and then you're subtracting them. So it doesn't really matter what this is because it's a negative number. And since I know this is a negative number, guess what? The answer to number 3 is no solution. If you ever hit a point where you're trying to take the square root of a negative number, then you have no solution. Which means this problem probably looks something like this. If I had to guess, just from looking at this, I can tell this is going to be a negative facing parabola. And then this one, if I were to rearrange this correctly, would be a negative slope of a linear equation. So if I were to map out what that should look like, if there's going to be no solution here, no point where they cross each other, then it's probably going to look something like this, if I had to guess. So I want a downward facing parabola, and then I want a negative slope above the other one. So this is what it's going to look like. Notice how they don't cross each other. So no intersection. That's what this means, okay? So these are going to keep going down forever. This is going to go down, but it's not going to go down fast enough to ever catch up with these. So that means that these will never cross. These two equations, these two right here, will never cross each other. So there's no solution. That's how you do that one. Okay, we're going to move on to elimination method. Okay, elimination method. The only way to do this really is just have an example. I think that's the best way to teach it. So let's go to an example from the book. We've got y equals x squared minus 3x minus 2. Okay? And then the other one is y equals negative 3x minus 8. Okay? So in order to use elimination method, what you have to do is you need to line these up to where something's going to cancel out, right? So I'm going to line these up. Y equals. We're going to have a line underneath them. And I need to decide if I'm going to use subtraction or addition for this. So I've got x squared minus 3x minus 2. Now I need to rewrite this so that way everything is underneath its counterpart. So do I have an x squared here? No, there's no x squared. So I'm going to leave that blank. You might even be good to write in a 0 x squared just to show that it doesn't exist. And then minus 3x. And then minus 8. Okay? So if I want things to cancel here, I'm actually going to put if I add these two things, it'll just make a negative 6x, so nothing will actually get canceled. But if I subtract here, then these y's will go away, and these will go away as well. So let's subtract. So y minus y makes 0. Now there's no y, which is kind of what I want. X squared minus 0x squared, so x squared minus 0 is just x squared. Negative 3 minus negative 3 is actually plus positive 3. So that's also 0x. And then negative 2 minus negative 8 is actually negative 2 plus 8. So this ends up being plus 6. Okay? And let's go ahead and rewrite this so there's no negative x, or no 0x here. So we got x squared plus 6. Okay? So we've got this one here, and we're going to subtract 6 from both sides. When we subtract 6 from both sides, we get negative 6 equals x squared. Okay, the easiest thing to do here is to just take the square root of both sides. Square root. And then this is where you notice you're taking the square root of a negative number. So we can automatically jump to the conclusion. This is no solution. Okay, that one was kind of easy. Might be better examples to look forward to on page 489, numbers 4 through 6 all. Okay, so do these and then we'll come back and go through them together. All right.